What's good, everybody? Professor Peters here today. So in my video today, we're going to go look over two problems dealing with how to find the difference in area when we're also working with polynomials. So guys, just always remember area, we're talking about multiplication and we're talking about length times width. So what we're going to do, right, they asked us to find the difference of the area from the following problem. So we have a smaller box, right? 3x times 2x minus 1. And then we have a larger box, which is x plus 8 times this trinomial. And what we need to do in this problem, guys, is find the area of each box separately. So let's do the first one. So we have 3x, and we're multiplying this by 2x minus 1. So what we're going to get for our area is 6x squared minus 3x. So let's just remember that, right? That's the area for the smaller box. Now what we want to do is go ahead and repeat this process, but we're going to repeat it for the larger box. So what we're going to do, and I'm going to use my box method, like I said, because I just think it's really good. It helps if you're a visual learner. So let's set our box up, right? So we set our box up. I'm going to have, let's see, x plus 8 on the left-hand side, and then we're going to have our trinomial on top. And just please make sure, guys, that you include your signs. So we have a negative 5x. Don't forget to include your sign, because that sometimes happens. And if we get our sign wrong, man, it's going to change the whole problem. All right, so we go through, we're going to take x and multiply by all three of those terms. And once we do, we're going to have x to the third power minus 5x squared and 3x. Just remember, properties of exponents are included, right? And now we're going to do the same thing with 8 and all three of these top terms. So we'll have 8x to the second power minus 40x, and we have a positive 24. So at this step now, we've multiplied, guys, but we're not done with this area for the larger region. So we're going to go through and combine our like terms. And remember that like terms usually run diagonal when we use the box method. So what that means is these are the two terms I'm going to add. So x to the third stays the same. 8 minus 5 is going to give me a positive 3x squared. Negative 40 plus 3 is going to give me a negative 37x. And we know 24 stays the absolute same because it has no like terms. All right, so we've got the area for both small and larger rectangle, Professor Peters. What is next? Glad you guys asked. What's next is this area, not area, this word right there. So it says to find the difference of the area from the following problem. So guys, when you see difference, just understand that's subtraction. That means we're going to subtract. But there's a very, very, very tricky special way to do this when we're talking about polynomials and functions. So obviously what we're going to do is we're going to take the smaller area from the larger. So what exactly does that mean? That means we're going to take this minus the smaller one. First mistake I see students do is they start off with the smaller area and they try to subtract. So what they'll do is they'll put 6x squared minus 3x, and then they'll say, okay, I'm going to subtract x to the third plus 3x squared. See, this is wrong, guys, because we're doing it in the wrong order. When we're finding the difference, we're usually going to subtract the smaller area from the largest one. And I'm going to show you guys how exactly to do that so that you don't get it wrong. So once we're doing this problem, guys, I always tell my students, put them in parentheses because we have to do a sign change. And if you watch my videos before, you know exactly what I'm about to do. And hey, man, good job to you guys, man, for keeping up and knowing what's coming. All right, minus, right? Because we're finding a difference. And then we have 6x squared minus 3x. So this is what I'm going to do. I'm going to switch to the color blue. And remember, when we subtract, this is going to change the signs of positive 6x is going to become negative, and now 3x becomes positive. So now, right, we took care of this sign change, we could actually subtract. So when we go through to subtract, this is going to be our final answer. X to the third stays the same, right? 3x squared minus not 6x squared is going to be negative 3x squared, right? This changed from positive to negative. Negative 37x plus positive 3, that's a negative 34x. And just remember that 24 has no like term, so it's going to stay the same. So when we find the difference of the area between the larger rectangle and the smaller rectangle, this should be our final answer. All right. So that's problem number one. We're going to switch over to problem number two. And in problem number two, they're going to give us a similar problem, but we're not actually going to go the whole way and solve it. And I'm going to explain to you guys what I mean. All right. So they give us this large rectangle. All right. Let's shade it some. So they give us this large rectangle and they say, hey, this is up top. This side length represents x. And on the side, our side length represents x plus 2. And they tell us that down here, this area that's not shaded is 7 by 4. And now they want us to write an expression to represent the area of the or represent the area of the shaded region, right? So this is what we're going to do. Or, well, this is what we're going to do. So what we're going to do, guys, remember, we're talking about length times width. So what we're going to do, right, we would multiply x times x plus 2. Because obviously, this is going to give us the whole entire area for the entire rectangle. So once we do that, we're going to get x squared plus 2x. Right, that's it, guys. X squared plus 2x. And we notice that to find the area of the shaded region, we're going to have to subtract. So now they didn't tell you guys to subtract. You have to assume because we want to find the area of the shaded region. Once we find the whole entire area, we now have to subtract this, which is 28. So to finish this problem off, our final answer would be x squared plus 2x minus 28. So this will be the expression to represent the area of the shaded region. I hope you guys found this video helpful. Just remember, like I said in our previous videos, guys, you know this stuff. It's just testing you guys to see how well you remember your foundations. And like I said, I hope this video is helpful for you guys. I'm Mr. Peters. Thank you guys for joining us today on Algebra 1 with Mr. Peters.